Hi everyone, welcome back to the channel. The Fermi Surveyor over here, and today we are going to look at the Topcon Tools software. Most of the times as surveyors and geomatic engineers, we do static surveys to get very accurate positions, especially when you want to set control points that you want to use for our work on a particular site or on our various sites. And then we do that using the GNSS equipment like Topcon, Tremble, and the Sokia GPS receivers. Now, the static survey is the most precise method of GNSS surveying. You can think of static survey as telling your GPS equipment that, my friend, stay here and record satellite signals for about 2 or 4 hours, and then give me the most accurate location possible of where I've set these machines. And then the data that we get from our GPS equipment are in what raw GPS format, and we would have to process them to be able to make meaning out of the data, to be able to get our locations of the various points that we took. And in today's video, I'm going to show you how to set up your Topcon Tools software to work with the local datum, which is the Ghana National Grid, which is an old war office system that is still in use in many surveying projects in Ghana. So we are going to look at it step by step in simple terms. If you are new to the software, don't worry, you are going to get it. So this is the welcoming page of the Topcon Tools software. Whenever you open it, this is where we do all the static survey data processing. You will start by creating a new job, then we will fill in the blank sections that we have here. So job name, let's name it as training, created by, you can do it, Engineer Taylor. And then at the comment section, you can give a description to the work that you are doing. So with this one, let's say cadastral data processing. Now the very important area is this part. Before we process any static GNSS data, we need to make sure that we set the data and the interface to the correct coordinate system, which is the Ghana National Grid, also known as the War Office system in our case that we are going to set it to. So now at the configuration section down here, which is where we are going to set the parameters for the Ghana National Grid. From the drop down, we can choose from any of the options, but let's leave it at design, and then we click on edit configuration so that we can set and then correct the parameters that we are going to use, the parameters in the system for Ghana. Okay, so now we are at the job configuration section, and the display section shows the number of digits that you want to leave your data to after the decimal point. Now the time, routes, and angles that you see over here, you leave everything as it is. And then in case you want to change the number of decimal points, we go back to the precision section, and then we reduce the number here from 3 to either 2 or 1, depending on what works best for you. But for the sake of the exercise, we are going to leave it at 3 that we have over here. Now under the coordinate system section, that is where we are going to define a new custom system settings for our work to be able to process the static data that we have in the local coordinate system. But by default, the settings that we may have over here may not always include the old Ghana grid, which is the Accra datum based on the Clark 1888 modified ellipsoid. Now to set it up, we'll first of all go to the projections, and from the drop down we can choose from the list of options we have here the coordinate system that we want to use. But we don't have any coordinate system yet, we haven't set any yet. And since we are now coming to set it up, but we don't have any to choose from yet, since we are now coming to set one up to use, what we will do is to create a custom projection. So you go to custom, and in the custom projection settings, we fill in the blanks spaces we have over here. So the name is GNG, which is Ghana National Grid, and then the projection type, we leave it to default, the transverse Mercator. And now at the meridian section, officially the value for the Greenwich meridian for Ghana is 0 degrees, which is the central reference line in the east-west direction of the grid. Also on the grid, everything west of it has a decreasing longitude of 1 degrees west or 2 degrees west, and everything east of it has an increasing longitude of 1 degrees east or 2 degrees east. So when we take the whole grid, we will then have to change the value from 0 degrees to 1 degrees west for Ghana. Now with the scale factor, we set it to 0.99975, and then the latitude, we will change it to 4 degrees 40 minutes north. Now with the fourth eastern and then the fourth northern, the coordinate system that we are setting it to, which is the Ghana National Grid, is in feet, and then the value for the fourth eastern is 900,000 feet. But over here we are seeing the fourth eastern to be in meters, which means we have to convert the feet to meters, and then 1 feet equals 0.3048 meters. So 900,000 feet will be equivalent to 274,320 meters. And with the force notings, we leave it at 0. And at the region section over here, we can type in Ghana, and then with the datum section, we can change it from the WGS 84 to War Office. We then click on apply. So now once we click on OK, you can see that the custom projection that we just created is being listed over here. So now we close it, and then we go back to the projection list, and then we select the projection that we just created. So we created a region for it, which is Ghana. Look at the drop down, and then our projection is here, and then we select it. And then you could see that the datum section here has faded out because we already set a datum for our work, which is the War Office that we selected. We just set it up over here, and then we are good. We leave the rest as it is, but in the coordinate type, we change it from the datum, latitude, longitude, and ellipsoidal height. Change it from that side to grid, and then you are good to go. So once all that is done, you can then save your configuration, give it a name, so GNG configuration, and then we can click on OK. Yes. So with this one, we can just call it back anytime by going to the list, call it back anytime that we want to use, and then load it into the system without having to go over all of this setup again. Now once all that is done, we would just click on OK, and then we can start doing our processing. But now this particular section over here, which you see over here as the geoid. Now most often than not, when we are doing our cadastral works, when we are doing our static survey, we use 2 receivers, and then we set one of the receivers, we use it as our base, and then set that particular receiver that we are using at our base on a known control point. Now if the control point that we are using, or that we have set the base on, already has a known autometric height, then you don't have to come here to this section to select a geoidal model to compute the height. This is because selecting a geoidal model like the EGM 2008 or the EGM 96, which is that's for Africa, tells the software that you want to automatically compute the autometric height from the ellipsoidal height of what the GPS using the geoidal separation and then using the geoidal model that you are going to select. But if your base that you set on the control point already has an autometric height, then you don't really have to do any conversion again, because if you are to apply a new conversion, then applying the geoidal model again will distort the height. So once you have a height with a control point, then there is no need setting up any geoidal model over here. You have to leave it blank like this, and then you set your coordinate type to grid, and then you click on OK. But if you want to bring in a geoid, so you have to go and then download the geoidal model online and then bring it over here. So once all that is done, we'll click on we go to units, and then our linear unit and angular unit is here. So the Ghana national grid is in feet, so we are going to use international feet, and then the angular unit we are going to leave it in degree, minutes, and what seconds. So once that is done, we click on OK, and then from here we click on OK over here, and then the whole interface of the software would open for us to start our processing. So this is the whole interface of the software that we can do our processing from. The bonus tip here is that I already have a saved configuration in my directories. So I've shared the file in my Telegram channel. So if you want to download a copy for yourself, there's a link in the description that will lead you to my Telegram channel that you can go there and then download. The name of the folder is called Geo. So inside the folder you have these parameters, these files over here, and then you just copy these whole files. And then once you copy these whole files, you just go to the directory of your Topcon Tools, and then you paste it there. So let's open the file directory, and then inside the Geo folder over here, you can just paste the files. You replace it, you paste the files all over there. That has an already saved configuration in the Ghana national grid for Ghana. So once I have that, then it means I don't have to go over all the configuration that, or all the settings that I just did. So you can just, after setting up your project name, giving the parameters, filling in all the parameters, at the edit configuration section, when you come to projection, you can go to more. When you come to projection over here, you just go to Africa. Now inside Africa you have Ghana. You click on the plus section, and then you will see the wall grid over here, which is the wall office. So you select that one, and then you change your coordinate type to the grid, and then you click on OK, and then you are good to go. So at the bottom section over here, you see the unit, which is in feet, the angular unit, which is for degree, minutes, and seconds, the grid, and then the Ghana national grid settings that you set to, and then you can continue your work. If you find this video helpful, please don't forget to like and subscribe for more exciting videos on the Fermi Surveyor Diaries.